5.8 says, in a certain human population, 30% of the people have superior vision, as in example 5.4. Suppose a random sample of 5 people is chosen and their vision examined. So here we have p is equal to 0.3, that's the probability of having superior vision, and we have 5 people being chosen in our sample. Let p hat represent the sample proportion of people with superior vision. So A says, compute the sampling distribution of p hat. Alright, so remember, p hat is basically the number of people we find with superior vision divided by the total number of people in our sample. It's the sample proportion. Okay, so I'm going to just form columns. So one is going to be the count with superior vision. One is p hat, which is basically the proportion with superior vision. And finally, what is the probability of that? So we can have 0 people with superior vision, 1, 2, 3, 4, or 5 people with superior vision. And the corresponding p hat values are 0.0 or 0.0, 0.2, 0.4, 0.6, 0.8, and 1.0. Each of these, let me just write, each of these we're using the binomial, which is n choose k times p to the k times 1 minus p to the n minus k. So for the very first one, we have 5 choose 0, 0.3 to the 0 times 0.7 to the 5. Okay, and if you multiply that out, you get 0.1681. The next one, 5 choose 1. I hope you guys can see this. 0.3 to the 1, 0.7 to the 4. And I'm just going to fill this out. 5 choose 2, 0.3 squared, 0.7 cubed. Here, 5 choose 3, 0.3 cubed, 0.7 squared. 5 choose 4, 0.3 to the 4 times 0.7 to the 1. And here lastly we have 5 choose 5, 0.3 to the 5, 0.7 to the 0. Okay. So going down this, we just have 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. And here we have the column of 0.3s, and that goes 0, 1, 2, 3, 4, 5. And the columns of 0.7s go 5, 4, 3, 2, 1, 0. So it's a nice little pattern there. And if you just crunch out all of these numbers, you should get 0.3602, 0.3087, 0.1323, 0.0284, and 0.0024. Okay, if my numbers are wrong, please let me know in the comments. But I think these are correct, and this is the sampling distribution of p hat. Okay, and basically it's just going to be this column p hat and the probability that p hat takes on that value. And so B says, construct a histogram of the distribution in part A and compare it visually with figure 5.4. Okay, and so when we do this, okay, we're going to so let me just go mark off 10, 20, 30, 40. So we start off, oops. 0.2 goes up to 0.36, so somewhere around there. This is just, I'm roughly sketching all of these. Oh, 0.6 is at 0.13, somewhere around there. 0.8 is down here, and 1.0 is really low, something around there, okay? And so that is that, and let me pull up the diagram of figure, was it 5.4? Is that what they asked? Figure 5.4. So figure 5.4, I don't know if you can see, is this thing. This is with n equal to 20. So here we've got n equal to 5, so that we can only take on 6 different values. And n equal to 20, it can actually take on 21 different values, but some of the probabilities are so small. So here, this shape is similar, except here with more, it forms more, I guess, a more rounder, more symmetric distribution looking thing. And over here, it looks a lot more skewed. So that is your answer to 5.8.